Hello students, welcome to the session 12 of course Water Supply Engineering in the third semester of Civil Engineering program. In the previous session, you learnt about intake and type of intakes. In this session, we will be learning about conveyance of water, types of conveying the water, and type of pipes used for this purpose. First, let us have an introduction about the conveyance of water. Water is transported from the source to the consumer in three stages. In first stage, the water is drawn by the intakes. In the second stage, this water is conveyed from the intake to the treatment plant. In the third stage, the treated water is distributed from the treatment plant to the consumers. This second stage, where the water is conveyed from the intake to the treatment plant, we call it as conveyance of water. As you can see here, the stage between intake and treatment plant, we call it as conveyance of water. Whereas the distribution of water is related to the transportation of water from the treatment plant to the consumers. Sometimes it so happens that the distance between intake and the treatment plant is of a shorter one. As you can see in this example, the water from the river is drawn by the intakes. From these intakes, the water is conveyed to the treatment plant. As you can see in this example, the distance between intake and treatment plant is very shorter one, not even more than a kilometer. From the treatment plant, the treated water is then distributed to the consumers. In this example, you can also see that the distance is also of a shorter one. The water from the treatment plant is distributed to the consumers. In some cases, the water is to be conveyed to a longer distance from the source. As you can see in this index map of the Ethinavale project, where the water from the Western Ghats is conveyed to the eastern districts of Chikballapura and Kolar through a longer distance of more than 270 kilometers. This is required when the place receiving water doesn't have any perennial source of water. You can see the photo of the project where the longer pipelines are laid to convey the water through a longer distance. Now let us know about type of conduits. According to the conditions and flow characteristics, the conveying of water supply is classified into gravity conduits and pressure conduits. Gravity conduits, as the name itself indicates, in these conduits, water flows under the action of gravity. The surface of water flowing is open to ambient atmosphere. The hydraulic gradient line in these conduits coincides with the water surface. Wherever there is a valley or depression, we have to carry these gravity conduits on supports. And wherever there is obstruction, hills, we have to carry these gravity conduits either by deep cuttings or by tunnels. We have to make sure that these gravity conduits run on a uniformly falling gradient so that water flows under the action of gravity. Problem with these gravity conduits is it takes a longer route to reach from intake to the treatment plant because it requires a uniformly falling gradient. Any sudden fall or raise, we have to provide it on supports and deep cuttings or tunnels. Because of these, the cost and maintenance cost of these conduits are more. Example for gravity conduits are open channels, aqueducts and tunnels. Open channels are of rectangular, trapezoidal, semicircular or of V shape. These open channels can either be lined or unlined. To prevent the seepage loss, it should be lined. Lining is a protection work on either side and at the bed to prevent the seepage loss. These lining materials for open channel is usually made of concrete, precast slabs, stone slabs or cement. As far as possible, the open channels for the water conveyance is avoided for the reason that pollutants can easily enter into water. That is the biggest disadvantage of open channels. And there is also loss due to evaporation and seepage losses. Next one is aqueduct. Aqueduct are similar to open channel but are supported on piers or pillars. When there is sudden fall, we cannot run the channel on that fall because again when we have to raise, we need pumping. But in gravity channel, water has to flow under the action of gravity only. So, to provide that facility, these channels are supported on pillars. Aqueducts are of shape rectangular, trapezoidal, semicircular. Usually they are of rectangular shape. Aqueducts are designed to run only 3/4 of its capacity. It is never allowed to run fully. Next one is tunnels. Whenever a gravity conduit encounters hills, either we have to go around the hills, of course it will take a longer route, or we can go through the hills by constructing tunnels. The tunnels are of shape semicircular or horseshoe shape. Water enters from the one side of the tunnel, flows under the action of gravity and emerges out on the other side of the tunnels. The inside of the tunnels are given protection work to reduce the collapse of the soil or rocky materials through which it was constructed. Next one is pressure conduits. In pressure conduits, water flows under pressure. The conduits are closed one, and these pipes always run fully. One of the advantage of pressure conduits over gravity conduits is, in pressure conduits we can run the pipeline in a shorter line between intake and the treatment plant. Since water flows under the pressure, we can follow the natural undulations of the ground, which is not possible in the case of gravity conduits. In pressure conduits, hydraulic gradient line always lies above the conduit. Sometimes they may fall below the conduit, but the hydraulic gradient line is never allowed to fall below 7.8 meters of atmospheric pressure. The pressure conduits are provided with gate valves, sluice valves, check valves, release valves, and pumping stations. Example for pressure conduits are pressure aqueducts, pressure tunnels, pressure mains. Wherever the intake is at lower elevation and the treatment plant is at higher elevation, we have to construct pressure conduits. But if the intake is at higher elevation and the treatment plant is at lower elevation, we can go for gravity conduits. In some condition, we can use both pressure conduits and gravity conduits, where the water is pumped to a higher elevation. From there, the water flows under the action of gravity towards the treatment plant. Here you can see the picture of a pressure conduit flow where the water is flowing fully under the pressure. Advantages of pressure conduits are, first one is their cost of construction becomes low because we can run it in a shorter route along the natural undulations of the ground. Second advantage is the maintenance cost is low compared to gravity conduits. In case of gravity conduits, we have to repair the breaches, strengthen the bank, and also we have to control the weed. Compared to gravity conduits, these maintenance cost can be reduced in case of pressure conduits. One of the biggest advantage of pressure conduits is the water flowing through the pressure conduits is not exposed to atmosphere, and then there is no chance of it getting polluted. Whereas in gravity conduits, the surface is free surface open to atmosphere, pollutants can easily enter into it. Next advantage is, in pressure conduit we can nullify the losses of evaporation and seepage, which readily occur in case of gravity conduits. As they are open to atmosphere, evaporation loss is more and seepage loss also exists. Next, the selection of material for a certain project. We have to decide that material after considering several factors, such as carrying capacity of the pipe, Depending upon the requirement of quantity of water, we have to decide the material for a particular pipe. Next, we have to consider the availability of funds and type of water to be conveyed, whether it has corrosive elements, whether it contains silts, that too we have to consider. Next one is initial and maintenance cost. It should be low as possible. And next one is durability. It should provide satisfactory service throughout its design period of life. Smaller diameter of pipes, although they are cheap, have higher frictional losses and cost of pumping is also more. Whereas larger diameter of pipes, although cost is more, frictional loss will be less. We should also consider the scouring and silting velocity. If we increase the velocity of flow of water, scouring of the pipe material occurs. If we reduce the velocity of flow, silting will occur and may cause obstruction. Usually, Agent Williams formula is used for designing closed pipes and Manning's formula for open channels. We use the formula Q is equal to AV, where Q is the quantity of water required in meter cube per second, A is the cross sectional area of the pipe, and V is the velocity of flow in the pipe. If we know quantity of water required and velocity of flow, we can find the diameter of pipe. Next topic is general requirements of pipe material. First one is cost of pipe should be less. We have to go for pipes which come within our budget. It should be durable and capable of withstanding both internal and external pressure. Internal pressure is from the water flowing inside the pipe. It will cause the tensile force on the pipe material. Whereas the external pressure is caused by the backfilling material or the traffic over the pipeline. Next thing we have to consider is frictional losses. It should be as low as possible so that we can maintain the pressure head. Next requirement is it should be available in all sizes so that we can pick the size which we required for a particular project. And the damaged part should also be easy to repair and replace. Next one is it should be easy to join. As a longer line requires a number of joints, if the process of joining pipes becomes easy, duration for completing the project becomes less. Next, let us study about type of pipes used in pressure conduits. Following are the type of pipes based on material of the pipes. There are cast iron pipes, cement concrete pipes, pre-stressed concrete pipes, steel pipes, galvanized iron pipes, plastic pipes, asbestos cement pipes, copper pipes, etc. In this session, we will focus on the first type, that is cast iron pipes, and remaining type of pipes we will be discussing in the next session. Cast iron pipes contains carbon content more than 2%, that is way more than steel. Because of this higher carbon content, cast iron pipes become strong and durable. They resist deformation, they resist corrosion activity, but the drawback is they become brittle. Because of their excellent resistance to corrosion property, they are extensively used for conveyance of water. The lifespan of cast iron pipes in normal condition is around 100 years. They are available in length starting from 3 meter and the diameter about 1200 mm or above. These cast iron pipes are manufactured by either horizontal or vertical sand molding or centrifugal process of sand molding or metal molding. These cast iron pipes are easy to cast because of their low melting temperature. Here you can see the photo of the cast iron pipes stacked one above the other. We can also have a look at the casting process of cast iron pipes. This method is of centrifugal molding process, where the mold is placed with socket fixture. The molten iron is poured into the mold. Because of the centrifugal force, the molten iron sticks onto the side of the mold, and once it cooled, it is taken out and cast iron of uniform thickness is casted. Classification of cast iron pipes as per IS 1536-2001. The cast iron pipes are classified into class LA, class A and class B according to their thickness, where the class LA pipes are taken as basis for deciding other classes. Class A allows 10% increase in thickness over class LA, whereas class B allows 20% increase in thickness over class LA. The advantages of cast iron pipes. First one is the cost is moderate. Because of their low melting point, energy requirement is low. The ingredient materials are also cheap. Labor cost is also more. Thus, the cost of cast iron pipe becomes low. These pipes are easy to join by socket and spigot joint, flanged joint, or by flexible joint. These pipes are highly resistant to corrosion. Because of their higher carbon content, they are strong and durable. They last longer, around 100 years in normal condition. The service connections, that is the connection from the main to the consumer property line, can be made easily by cast iron pipes. Disadvantages of cast iron pipes are, as we discussed earlier, because of their higher carbon content, they become brittle and they crack easily if not handled properly, either during transportation or during pipe laying. Next disadvantage is, as the life of pipe increases, their carrying capacity decreases as high as 30 to 40% due to the formation of tuberculation. Tuberculation is the formation of mounds of reddish brown iron oxide on the inner surface of the cast iron pipes due to the action of microorganisms that are present in the water which it is carrying. Cast iron pipes are not suitable for pressure greater than 0.7 Newton per mm square. Once the pipe of size increases beyond 1200 mm, they becomes heavier and uneconomical to use. These are the photos of cast iron pipe failures where the failure occurred due to high pressure applied beyond its permissible limit or due to the formation of cracks. Now it's time for multiple choice questions. Question number 1. In gravity conduits, the hydraulic gradient line lies A. above water surface, B. coincides with the water surface, C. below water level, or D. none of the above. And the answer is B. coincides with water surface. Since the water flows in gravity conduits freely open to atmosphere, the hydraulic gradient line coincides with the free surface of the water. Second question. An artificial channel for conveying water, typically in the form of a bridge across a valley or other gap, is called A. aquifer, B. canals, C. aqueduct, D. tunnel. The answer is aqueduct. Aquifer is a water bearing strata under the ground. Canals run not on supports. Tunnel goes through hills. Aqueducts are the structures which runs across a valley supported by pillars. Question number 3. Water flow through aqueduct is designed to run maximum of A. full level, B. 3/4 level, C. 1/4 level, or D. none of the above. The answer is 3/4 level. Water through aqueduct is never allowed to run fully. 1/4 level is too shallow, so it is allowed to run maximum of 3/4 level. Question number 4. Biggest advantage of pipe conduits over gravity conduits for drinking water supply is A. low maintenance cost, B. low construction cost, C. no chance of water getting polluted, or D. no evaporation loss. The answer is C. no chance of water getting polluted. Although all A, B, C, D points are advantages of pipe conduits over gravity conduits, the biggest advantage is in pipe conduits there is no chance of water getting polluted. Question number 5. Pipe material should be 1. Easy to joint, 2. Durable, 3. Have maximum frictional loss, 4. Replaced easily. Which of the statements given above are correct? A. 3 only, B. 1, 3 and 4 only, C. 1, 2 and 4 only, or D. 1, 2, 3 and 4. And the answer is C. 1, 2 and 4 only. What we can expect from a pipe material is it should be easy to join, it should be durable, it should be replaced easily. It should not have maximum frictional loss. It should have low frictional losses. Question number 6. The final selection of material for the pipe depends on A. Durability and period of life, B. Availability of fund, C. Initial and maintenance cost, D. All of the above. And the answer is D. All of the above. While selecting material for the pipe, among other factors, we have to consider these factors too, A, B, C and OK. Question number 7. Lifespan of cast iron pipe is A. 100 years, B. 10 years, C. 200 years, or D. 6 months. And the answer is A. 100 years. We can expect under normal condition cast iron pipes to last longer, around 100 years. Question number 8. The type of pipe commonly used in water supply schemes is A. RCC pipes, B. U1 pipes, C. Cast iron pipes, D. GI pipes, that is galvanized iron pipes. And the answer is cast iron pipes. Because of their high resistance to corrosion and durability, cast iron pipes are extensively used. Question number 9. The advantages of cast iron pipes are 1. The pipes are easy to join, 2. The pipes are light in weight, 3. The pipes are highly resistant to corrosion, 4. The service connections can be easily made. Which of the statements given above are correct? A. 1 and 4 only, B. 2 and 4 only, C. 1, 2, 3 and 4, D. 1, 3 and 4 only. And the answer is D. 1, 3 and 4 only. Advantages of cast iron pipes are they are easy to join, highly resistant to corrosion, service connection can be easily made, but they are not light in weight. They are heavy in weight. Question number 10. Tuberculation in pipe is A. Formation of small mounds of corrosion on the inside of pipe, B. Cracking of pipe due to high pressure, C. Bending of pipe, D. Penetration of roots through pipe. And the answer is A. Tuberculation is the formation of small mounds of corrosion on the inside of the pipe. This happens due to activity of microorganisms present in the water media that is flowing through that pipe. This ends the session. I like to thank all my team members who helped me to bring this session to all of you.